So from O level, how do I find length of a sector? Let's use O level, then I'll show you how you apply to A level. Length of a sector, how do you find this? From O level. Length of an arc. Let's start with the length of length of an arc, which is perimeter of an arc. How do you find it?
It's like theta over 360.
Yes. Multiply by 2 pi r.
Wait, what?
Circumference.
Yeah. Wait, what? That's not okay. Yeah. I just normally say pi d. I don't know. I get it's the same thing. It's the same thing. I know.
Pi
times pi d, and then plus r. Right? That's like
that would be
perimeter.
Yeah, that would be perimeter of a sector, not an arc. If you do that for an arc, that's not correct.
I thought you said perimeter of a sector, sir.
No, I said an arc. I changed it. Okay? An arc. So now look at this. From A level now, what you now need to know is that pi is equal to what? 180 degrees. If you can write that down. Pi is equal to 180. You don't need to explain that. So 2 pi is equal to what? 2 pi is equal to 360 degrees. Which means now let's rewrite this formula. So this is now theta over, what is 360 everyone? 2 pi. Multiply by 2 pi r. Which means you cancel the 2 pi. And what's your new formula for A level? Is simply theta r. That's the length of an arc. Is that clear? Right?
Yes, sir.
Yes, sir.
Okay. That's the length of an arc. In radians, so this works if the angle is in radians. Which means you change your calculator, the mode to what? To radians for the angle. Clear? Now, having said this, let's now do the length of the length of the arc. So the length of sector. Length of sector is equal to O level theta, like what he said, over 360 multiplied by 2 pi r plus 2r. So this A level is theta over 2 pi multiplied by 2 pi r plus r. This cancels, So you simply have theta r plus 2 there. Making sense? Length of a sector. Now, area of a sector. How do I find the area of a sector? So these are simple formulas that you need to know. O level, how do I find L? So if you know the O level, you can play around. If you forget the A level. Theta over 360 multiplied by pi r squared. Is that correct? Because a sector is a fraction of a what? Of a circle. So now let's change to A level. Theta over 2 pi multiplied by pi r squared. This cancels. So you've got half theta r squared. Clear? Area of a sector. Clear now? Making sense?
Yes, sir.
That's all you need to know. Then you apply that. The rest is O level. Let me just show you now. It's the application that you need to be careful with. The rest is simply O level. It's an easy topic.
Sir, please just wait. You're moving a bit too fast.
I'm too fast. Wait, didn't I copy which part? This part? Okay.
Yes, just.
I was slow. Okay. So I said the area of a sector is half theta r squared. And the angle has to be in radians when I'm using that formula. Clear?
Yes, sir. Okay, you can move on.
Now, moving on, I simply need to do 2 or 3 questions together where we apply this. Then we see. So it's always in exams, this one, this topic here. They love this topic. Hold on. Circular measure. in the A level section. A level maths. Circular measure, geometry. That's what done. There's a form 5 sound.
Sir,
Yes, cousin?
do you take A-level Chem?
Yeah, but I've been busy. Why asking? I take I take maths, physics, chemistry, computer science. It's A level. You want lessons for chemistry? I have to let you know. You need to check with my timetable. Then advise you. Just order. So you thought I only take maths? I take all sciences except biology. I can't take biology. Otherwise you fail. Biology at A level. Where did I save this? Secular measure there. Yeah. You're asking me about secular measure. I knew that I saved it. Because we were doing that with the group, another group last year. Okay, then. Who was asking about chemistry? Tawana?
Yes, sir.
I told you that day. A piece of wire of length, whatever, is bent to form a what? Perimeter of a sector, of a circle. Okay, show that the area, you see, so that the area of the sector is what? In that is given by this formula here. So how do you do that? 3 marks. A piece of wire is bent to form what? Perimeter of a circle. How do you do that? Perimeter of a circle. What did you say was the formula for perimeter? Who remembers?
Wait, so you mean of a sector of a circle?
Look at this. Yes. We are bending the wire, a piece of wire of length that is bent to form perimeter of a sector. Like this, huh? Of radius, this. Clear? Show that the area of the sector, is equal to what? Is equal to that. Let's use our formula together. Don't be intimidated by this. Let's use our formula. How do you find length of a sector? I told you just now. Length of a sector, how do you find it? Length of a sector.
Say that's
Theta what?
is theta would
Yes, we
be
said is
60
theta.
or 2
Didn't you say that? Yes. No, I'm saying I know, right? We said theta over 360 times 2 pi r. But I've showed you that now, right? We now change this to radians. It's now theta over 2 pi multiplied by 2 pi r. Even if you forget, this cancels, this cancels. So this is your formula here. Clear? Which means what is theta?
Yes, sir.
Theta is equal to the length divided by what? By that. Huh? And what is the length in this question? It's 24 over what? Over that. So that's our theta here. 24 over our radius. Okay. Now, what is the formula for area? I showed you. Who remembers quickly? The A level formula for area of a sector is half what?
Half theta r squared.
Yes. Well, now you can look at the formulas, but the more you do them, the more you remember. Half theta r squared. So now, I am simply saying half. What is theta here? 24 over what? Half multiplied by 24 over, let's see if it works. So that the area is given by that half theta r squared. Okay. You don't really get the same answer. Area of the sector. I lied here. I lied, and everyone was quiet. What is 24? 24 is not length of an acre. It's length of a what? And everyone was quiet. Isn't that length of a sector? Let's use our formulas. It's length of a what? Perimeter of a sector. What formula did I give you for perimeter of a sector? We used the wrong formula. What formula did I give you?
You gave us pi r plus 2r. Theta r, sorry, plus 2r.
Yes, like this. Right? Making sense now. So to make the subject of the formula then, theta, sorry, the subject of the formula. Why? Because when I say area of a sector, I say I have theta squared. And there's no theta here. So that's why I want to make theta the subject of the formula then. Now move that the other side is 24 minus 2r is equal to theta. Divide both sides. So theta is equal to 24 minus 2r over like that. Then replace it there. So area is equal to half brackets 24 minus 2r. Can you see that? Divided by what? By r, like that. Making sense? Multiply by what? By r squared. That making sense, right?
Yes, sir.
I can now do this individually. Half multiply by, if I want to remove brackets, that is 24 over. Okay, let me do this here. This one cancels that from maths. If we do that stage, we divide there so that we eliminate the denominator. So I left with the half brackets 24 minus 2r like this. Was this divides that. Now we can multiply by half. So if you multiply by half, we get 24. If you multiply by half, you cancel the 2 and you get minus r squared. Done. Can you see that?
Sir, but there's an R after the 12.
So where did mine go? Did I make a mistake somewhere? Let's see. 24 theta r minus that. Let's see. Then we moved the 2r that side. Then we divided by r, which is correct there. Okay. Then we had, yes, it's correct right there. You see my mistakes here. What happens if you multiply by the r there? Everyone? I didn't multiply. This r affects everything in the bracket, right?
Yeah.
I didn't do that. Clear.
Okay, yes, sir. Yes, sir. Yes, sir.
That's all. Now, can you do that? That's completing the square. You have learned that. They're saying do that. Complete the square quickly. So that this a is in that form. Can you complete that square there? 30 seconds is easy. Complete the square. Let's complete the square there. Express a in the form of that, where a and b are constants. Where a and b are constants. Give on there. Making sense? Done? Oh yes.
Is it r minus 6 squared minus 36?
Not sure. I don't know the answer. We have to work it together. Completing the square, I would say move this do the usual way that you are used to, like this. Then there's a problem here. I can't complete the square if this is a negative. Huh? So I take away what? The negative like this. That's the first operation there. Maybe that's what you're trying to do first. Huh? Then now when I have this, because when I take out this, I go back to this. Now I try to complete the square. But now I can use a big bracket like this. Then this minus 6, that's what you're saying, squared. Then if we square this, we subtract what? 36. Huh? Then we close the big brackets. But be careful now when you're taking out the negative. Now the negative, reintroduce the negative. So it's minus brackets minus 6 squared. Negative times negative, everyone, positive. 30 what? Making sense? Rewriting in this form
Yes, sir.
is 36 minus brackets minus 6 squared, which means your A is 36. You see that, your B is 6.
Yes, sir.
There.
Wait, 6 or minus 6?
It's minus B.
6.
Minus B, huh? It's 6, huh? Not negative 6. Huh? Because there's a minus B there.
Okay.
Clear? Now, given that R can vary, state the greatest value of the area. Greatest value of the area. Greatest value of the area. Okay, R minus 6 squared minus 36. And find the corresponding angle. So what will be the greatest value for your area? Find the greatest value of area, 36 minus. So you're subtracting 36 minus something, huh? Clear? Which means what's your greatest value of area? If you are subtracting from 36, huh, it means your greatest value is what? Is 30 what? 36. Are we agreeing there? But this is a
Yes,
minus
sir.
a squared
sir.
value. Huh? So a squared value will always give you a positive. So if you subtract a big positive number there, you get a negative, huh? which is wrong. So it means the greatest value there is 30 what? 36. Huh? Is your greatest value for the area. So 36. Now they are saying find the corresponding angle. I go back to what I had removed earlier when we did this. We said 24. I said 24 is equal to theta r plus 2r, I think. Yes, and then we had said theta was equal to 24 minus 2r over like that, the angle. So now, when that area there, when the area, look at this, when the area is 36, it means your r, what will be your r here? This has to be 0, means your r is equal to 6. Or 6 minus 6 gives you that. So your r there is 6. So you're saying 24 minus 2 multiplied by 6 divided by 6. So 24 minus 12 is 12 divided by 6, which means it's 2. So it's 2. The angle is 2 in the radians. Huh? Remember, not degrees. When we are doing this, we are always working with radians, not the degrees. Huh? Now look at this now. You have to apply your O level. Now in the diagram, AYB is a semicircle with diameter AB, with AB as diameter. AYB, AB is diameter, AB, all that one there. Okay. AYB is a semicircle. AYB, let's see the semicircle that they're talking about. I can't see clearly. AYB, okay. And this is the diameter. Now I see what they're talking about. Diameter of a circle with center O. Okay, comma with diameter. Then OAXB. OAXB is a sector of a circle with center or radius that angle A or B is equal to 2 theta radians. Find an expression in terms of what? Theta and for the area of the shaded. You see why I'm saying you are now applying all of. How do you find the area of the shaded? Let's think. I'm not saying the calculations. How do you find? We say area of what minus area of what? Let's just analyze this. How do you find? This is where you need to apply also what you learned at O level. How do I apply that area of the shaded region? What do I find first?
So would you not
Shaded.
the area of the semicircle?
Semicircle. Which semicircle? You mean the large semicircle? Yes. Area
Yes,
of semicircle.
and then minus the area of the sector.
Area of the sector, right? Your sector is this one here. Can you see? This is your
Yes,
sector.
sir. So I'm saying.
So if yes.
Yes, sir. Yes, sir.
But if you say semicircle, you're saying this area here. Because what I eventually want to take away is.
Okay, I think I understand.
You see, no? So what do we do there? We want to find the shaded.
So can you say? Can you first of all say area of sector minus? I don't know if this is possible.
Which area of sector? You mean this one here?
AB, yes, sir.
We can say area of sector like what you say, area of sector. A O B. A O B, yeah? That's the sector, this one. Yes, that's correct. Minus area of what? Triangle. I thought you were going to say that. Minus the area of the triangle, we get this small area here. Can everyone see this? If we say area of sector minus area of the triangle, minus area of triangle. What triangle are we talking about? OAB. OAOB. It gives us this here. Making sense? First. Then when we have this now, we can now say area of the what, everyone? Area of the semicircle minus the area that we find here. Because it's that small area there. Is that making sense? Everyone?
Yes, sir.
You guys are quiet? Okay. Now let's do that. What's the area of the sector first? This sector. Use your formula. We said the area of a sector is half theta squared. What is our theta now? Is 2 what? Is 2 theta. So it means area of that sector is half. The radius is simply r squared multiplied by 2 theta. Because our theta is 2 theta radius. Clear? Then these 2 cancels that. So you are simply left with that area there is r squared theta. Making sense so far? Okay?
Yes, sir.
Now, area of the triangle, how do you find area of a triangle from O level? If you are given 2 sides and an angle, use half AB what? Half AB sine theta. Do you remember that from O level? Half AB sine theta. So I'm saying half.
Yes.
A is that, B is that, half R squared. Sine the angle between, which is 2 theta, like this. Clear? So it's minus half R squared sine 2 theta. Are we together? Right? That's to get this part here. This part here. That we are talking about here. To get that part. Now, okay, fair and fine. We have that part now. We now need the area of the what? Are we given the diameter? Area of the semicircle?
No.
We are not given the diameter. Do we agree that we are not given
So
the
not.
diameter? We are not. Huh?
We are not.
So how do you find the diameter? AB. We have to find AB first. For us to say half pi r squared. How do you find the diameter then? You've forgotten. This is R then. And I want to find AB from O level. How do I find the diameter? I'm given two sides and an angle between. How do I find diameter? Diameter. Isn't diameter cosine rule to find AB? Are you forgetting cosine rule? Diameter.
Yeah, I'm forgetting the formulas.
If I have two sides and an angle between of a triangle, I can now find the diameter. The diameter there, AB squared, is simply equal to this side squared plus that side squared according to O level minus 2 times that cos the angle between them. So 2 times r squared cos the angle between them is 2 theta. Make sense? So you're saying a squared. So
Yes,
this
sir.
is as 2r squared minus 2r squared cos 2 theta. Remember, this is AB squared from O level. What you want is AB, which means it's the square root. Okay. Now, what you can do before you do that, you can say r squared brackets, or if I want to take 2 like this, brackets 1 minus cos 2 theta, like this. Then AB, I take square roots now. If I take square root of 2 is root 2, square root of r is r. So root 2 r brackets 1 minus cos 2 theta. That's my AB, my diameter. Making sense or not making sense?
Yes, sir.
Yes, sir. Thank you.
That's our, we now have our diameter. Then since we now have our diameter, we know that we are saying we now have the area of that thing. We have to subtract, so we have to find half. Okay, if I wanted to use the diameter from O level, area of a sector, of a circle, is pi r squared. Clear? And in terms of diameter r is equal to 2d. So if I was to multiply is pi multiplied by diameter, radius is equal to diameter over 2. So it means d over 2 squared. So in terms of area of a circle using the diameter, it's actually equal to pi d squared over 4. That's the area of a circle using diameter. But now it's half of this. So we are dividing by half. So semicircle, if we divide by half, it's actually pi d squared. Can you say that? D squared over, follow me, d squared over, you're dividing by half, over what? Over 8. So remember, this is our d here. What is the d squared? The d squared, I square everything there. So if I square, I'm squaring that. That's the d squared. So the d squared, you go back to this. The d squared is 2r squared brackets 1 minus cos 2 theta is our d squared. So that's the one that you are plugging in to this formula and dividing by 8 like this and subtracting this that we found there. Okay. Maybe we started with I don't want to intimidate you. We started with a tricky one. Let's go back to the easy one. So come back to this here, so that you find that it's not difficult. You are applying your O level there. In the diagram, AOB is a sector of a circle center or radius that the point C on AB is such that the angle that is a right angle. Okay. AOB is A in radians, is A radians, and is such that AC divides the two sectors into two equal what? AC divides AC divides the two sectors into two equal areas. AC, two equal areas. Like that. Two equal areas is the keyword. Show that sine theta cos theta is equal to half A. Sine theta cos theta. So what do we do?
Oh, so
Yes.
they show the theta as A. Okay.
Yes, so we're saying the angle here is A in radians. Huh? Clear?
Okay. Yes, sir.
Now we are saying AC, follow what they're saying, divides the sector into two equal what? Into two equal regions. Huh? So those regions are equal. Okay. Two equal regions. Let's work with what they said. Two equal regions is the keyword here. That region is equal to that region. Now, this is a triangle here, but we are saying the sector divided by 2, because this is a sector here. Are we agreeing? It's a sector like that.
Yes, sir.
Now, if it's a sector, how do I find the area of this? OAB. From O level. What did I say? From A level, sorry. We said it's half what?
Half.
R squared theta is the area of the
Yes,
sector.
sir.
So it's half R squared. What is the angle? A. Okay. That's the area of the whole thing. But it's being divided by this line into two equal whatever. Clear? Now, if it's being divided like that, my question to everyone now is, what is the area of this? Because this one here is being divided into two equal areas. So what is the area of this here? Analyze your shape. What is that area? Can we find OC here? OC. Can we find OC from O level? Because I can't find the area. The area I have to say half AB sine theta. But I have got this, but I don't know what OC is. How do you find OC? We are given the longest side of a right angle triangle, which is hypotenuse, and we want to find adjacent. So what do we use from O level? Don't we use cos? A and H, isn't that cos? Everyone?
Yes, sir. It is.
We have lost it.
Yes.
The rest we have lost it. So it's cos. Cos A, the angle, is equal to adjacent, which is OC, which I can say X for now. I don't know that. Divided by what? By that. Which means my X is simply equal to R cos what? Cos A. Do you see that, right?
Yes, sir.
That's my distance here. Now, if I have the distance, I can now plug in to find that area there. Because area is half AB sine theta. So it's half, this one is R multiplied by this one here, which is R cos theta. Follow me? Multiplied by what? Sine the angle. What is the sine? It's sine A, yeah? Like this. So this is A here from this. Can you see that? We are almost there. So we're saying half. This gives us the area of that. Making sense, everyone? But
Yes,
that area is half the area of the whole what? Semicircle. This is the area here. So this area that we found here should be multiplied by 2 for it to be equal to this area here, which is half r squared a. Is the area of the semicircle, and this area of the triangle is half the area of the semicircle. Clear? Making sense now? Multiply this. Yes?
Yes, sir.
Is it clear or not
No,
clear?
it's fine.
Okay, so it's what?
It's
Don't
getting-
worry.
no, that's
Don't
fine.
worry. Don't worry. Don't worry. Don't worry.
But I have a question.
Yes. Let's go back here. Let's go back here. And now, do you understand that this is divided into 2 equal areas? Huh?
Yes, sir.
And by the area of the semicircle in A level is always given by half r squared theta. So that area there is half r squared. What is theta here? It's A. Then the area of the triangle OAC is actually half. That's what I meant. Huh? It's actually half the area of the sector. Half area of sector. Do you agree? Half area of sector. It's half times the area of the sector. So which means that area there, area of OAC, is equal to half multiplied by the area of the sector, which is equal to half r squared a, if you want to put it that way. That's what I meant. Huh? Half, because it's half, it's divided. It's half that area there. Then that area there, we can't find it without knowing this. Huh? Because we need 2 sides of a triangle and an angle between. So this is the longest side, and this is our adjacent. So if you go to your soccer towel, we are saying cos the angle, which is A, is equal to the OC divided by the longest side, which is R. Multiply, you get X is equal to R cos A. That's this here. But how do I find area of a triangle, of a non-right angle triangle, half AB sine theta, which is equal to half. Multiply by what is this distance, R. What is the other distance, OC? It's R cos, like that. Sine what? Sine the angle between them. What is the angle between them? Alpha. That gives us quarter r squared a. I simply multiply this. Making sense now, right? Slowly.
Yes, sir, it is.
Now multiply everything if you want by 4, if you want that way. If you multiply by 4 there, okay. So if you multiply by 4, because what I simply want is to eliminate the denominators. Huh? I will have this side, I will have 2r squared cos a sine a is equal to r squared a. Clear? Divide both sides like that. Then I actually have the answer there. Sine a cos a is equal to half a. Done. Yes, Wimbai, do you have a question?
No, I don't.
You're saying it's quite handy. It's O level. We are applying O level and A level.
Okay, that makes sense. So I have a question.
Yes.
A small question. So I don't know where I heard this from, but so AB sine theta also applies on right angles. Is that
What?
is that true? Half AB sine theta, so it also applies on right angles.
Yes, it can apply. The reason why we ignore it, the reason why we ignore it, look at this one. You've asked a very good question. The reason why we ignore this, if we say, let's say we've got 7 here, and we have 9 here, and we say half base times height, because it's right angle. Do you know the reason why we avoid this from O level?
Why is that?
What is sine 90? Because the angle between the base and the height is 90. What is sine 90? Sine 90 is 1. That's why we drop it and we say half AB or half BH, yeah? Because the angle is 90. Sine 90 from your calculator is what? Is 1.
That's 1.
So that's why we drop the sine theta, because that angle is 90 degrees.
Okay, that makes sense. That makes sense.
Tawana Yabe, we lost princess there.
Yes, sir. My sister had went.
It's fine, we are recording. You can get the recording. Now, it is given that the solution in part 1 is A is equal to that. Correct to 4 decimal places. Find the ratio of what? Of the perimeter of? Find the ratio of the perimeter of OAC to the perimeter of the region ACB. Now you simply use, it's now easier. You simply use what I was removing, the area of the semicircle and the area of the what? Mune cappuccino gana. Oh, na follow that. Mune, oh sorry. Is that clear there? Not clear. So, let me give you an early break. Okay, we'll continue this whole week on this, step by step. But it's not difficult.
That's okay.
It's not difficult. It's simply, so what you need to do, maybe before the next lesson on Monday, is can you revise your cosine rule, sine rule, and Churchill tower? Because you have to apply them at A level. You have to apply them. I think you saw with this question there. You have to apply that. So revise that part. Clear?
Okay, sir.
Before our next
Yes, sir.
Okay.
Thank you.
You're welcome.
Thank you very much, sir.